Okay, and here is problem 714, installing wireless. This is another CDMA system, and we have two users only this time, and we are using Walsh codes as follows. Okay, and it says to find the receiver output for various cases, and there's cases A, B, C, D, etc. And in case A, user A sends a 1, but user B sends nothing. And so if user A sends a 1, then user A is going to send the exact Walsh code. Okay? If user A had sent a 0, then we invert the Walsh code as in part B. Okay, so we send the Walsh code. The receiver then correlates with that same Walsh code and gets all pluses, and the sum of those values, the sum of 8 plus 1s is 8. Okay, and that indicates that a 1 bit was sent. For part B, we're going to transmit a 0, and B isn't going to transmit anything. So user A sends a 0, user B sends nothing. When any user sends a 0, they invert the code and send that. So now we have plus minus plus minus plus minus instead of minus plus minus plus minus plus. And now the receiver is going to use user A's Walsh code to correlate, and he's going to get 8 negative 1s, and the sum is negative 8, indicating that a 0 was sent. Okay. Now it gets more complicated when we start sending more bits, and we have we have all 4 different combinations in parts C, D, E, and F, where user A and B are sending either a 1, 1, a 0, 1, a 1, 0, or a 0, 0. Okay, and in each case, you go ahead and figure out what was transmitted, and then so now we have 2 users transmitting. This is actually supposed to be B here. We have 2 users transmitting, and so what goes through the air is their sum, the sum of these values. Okay, and so now the possible values are negative 2, 0, or plus 2. And so I'm going to go ahead and use the actual numbers rather than just the pluses and the minuses. But then the transmitter is going to correlate with user A's waveform. It's sort of unclear in the statement of the problem that the receiver is going to be using user A's code for all of these problems. But that's what I did here, and I think that's what he meant. And so when I correlate with user A's code, I get 2, 0, 0, 2, 2, 0, 0, and 2, whose sum is 8. And that is now, here's what's transmitted, here's now what the receiver gets when the receiver tries to detect user A's bit, and a plus 8 means a 1 was sent, and that is what user A sent, a 1. Okay? If we were to take this transmitted signal and correlate it with user B's code, we'd also get a positive number, and indicating that B is sent a 1 as well. For parts D, E, and F, we just repeat the same thing. And so I kind of added a summary here. We're going to add the 2 users' signals together to get what was transmitted through the air, and then we're going to multiply when we do the correlation at the receiver to get the receiver's output and sum, which yields the bit. And in all 4 cases, it works out. In all 4 cases, I've used A's spreading code at the receiver, and we get A's bit. We get a 1 because it's positive. For part D, we get a negative 8, which indicates A sent a 0. For part E, we get a plus 8, indicating A sent a 1. And for part F, we get a negative 8, indicating that user A sent a 0. Okay, so it works. For G and H, it's a little bit more difficult, and we can't just use plus minus 1 because it says that user B's signal actually has twice the power of user A's signal. And we do 2 different cases, 1, 1, and 0, 1. And it turns out that if we're going to use A's spreading code, we're going to get the correct bit for A in both cases. We get a plus 8 here, corresponding to user A sending a 1. And for part B, we got a -8 indicating that user A sent a 0. And so it worked. But in general, the CDMA is going to work well only when the users have the same power being transmitted. That is, that when the superposition of the signals is received at the receiver, that received signal contains equal contributions from all users. Here we have just 2 users, and it doesn't really illustrate very clearly that unequal signals can cause rise to errors in the bits, but that's the idea of this. And so that is problem 14. Hope that helps.